Welcome back, Lecturer Joe here. In previous videos we looked at what was meant by current in electrical circuits, and by that we meant the actual flow rate of the electricity around the circuit. So now it's time to take a look at what's meant by voltage. This very simple circuit, we've just got a battery, 12 volt battery, and a resistor, and you know there's going to be a flow of current around here, but we're interested this time in what the voltage is on this circuit. Being a 12 volt battery, it should be fairly obvious that if we put our digital meter here, which measures voltage, across the battery, we'll get a reading of 12 volts. Reading across the terminals of the battery, we get 12 volts. And if we connect our meter across the terminals of the resistor, we still get 12 volts. And that's because it's really the same thing, it's the same place. If we measure here, we've got 12, here, 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 the whole way across. 12 volts between red and black, between the positive and the negative. So in this, the simplest of circuits, there really only is one voltage that can be measured, and that is 12 volts. So let's change our circuit a little bit. We've still got our 12 volt battery here, but now we've got two resistors. There's still only one current flow because there's only one circuit here. The current's flowing around like this. But now there's more than one place we can put our meter. We could place our meter across the battery, or we could place it across one of the resistors or the other resistor. So let's see what those are going to read. If we place it across the battery, it's going to read 12 because it's a 12 volt battery. But if we now place it across the top resistor, we read 4. Across the bottom resistor, we read 8. So let's draw those on. Across this top resistor, we read 4 volts. Across the bottom resistor, 8 volts. And the first thing you notice there is that these two add up to give you the 12. So 4 volts here, 8 volts here, and same as before, from the very top to the very bottom, 12 volts. So in terms of why or how we would determine that we've lost 4 volts here and 8 volts here, this resistance is only half the value of this resistance. So there's only 4 volts dropped across that. And then here where you have twice the resistance, twice that number. So the ratio here, 4 to 8, is the same as the ratio here, 10 to 20. A little bit later we'll look at how to work this out mathematically, but first we should look at this just in the same way we looked at the determining how much current was flowing, in terms of just ratios, in terms of this being half the value of this resistance means that you lose half the voltage here as you do here. And the only way that you can split 12 into two numbers so that one of them is half the value of the other is 4 and 8, because they both got to add up to 12 in the end. So let's look at some other examples.